Alright, today we're going to be looking at two algebra concepts. One of them is distributive property, and the other is combining like terms. Both are topics that you did cover in middle school. So, starting with our formal definition of the distributive property, that would be if we have a number outside of the parentheses times a sum, so we have A times the quantity B plus C. We can distribute that A, multiplying that A to everything in the parentheses. So then we end up with AB plus AC. How could we show that in a drawing? Well, I could show my stick person coming around and handing out a homework to this stick person, and then making sure they hand out a homework to this other stick person, and a homework to this one. So you can distribute to more than one. Some numeric examples here. Distributing the number 3, and I'm going to actually show every step here. So it would be 3 times 2 plus 3 times 5. And notice I wrote my, I wrote those different. The multiplication is different. I wrote one with the dot for multiplication, the other one with the parentheses, just to remind you that you can do either one of those. And then I would simplify. 3 times 2 is 6, plus 3 times 5 is 15. And then we could actually simplify further, but here we're just showing the distributive property, so we're not going to simplify it further. Same thing on the second example, except now we don't have a plus sign, we have a minus, which is fine, because you can do this with addition or subtraction. 4 times 9 minus 4 times 9 is 36, so it would be 36 minus 28. Now algebraic, since we're in algebra, that's what we're going to want to be doing, is using distributive property algebraically. With algebraic, we wouldn't be able to take it another step. We'd be able to simplify. Like here, we could simplify that and say that that is 21. But in algebraic, we can only do that if they're like terms. So distributing this 5, we get 5 times G, 5 times G, minus 5 times 9, which would then be 5G minus 45. For number 2, a little bit more complicated because now we have more than one or more than 2 things in our parentheses. So we're looking at that one. We can distribute. I'm going to do it in a different color since it's so close together. 3 times 2x squared. That's 3 times 2x squared. And then 3 times 4x. And minus 3 times 1. And then we'll clean that up a little bit. 3 times 2 is 6x squared. Plus 3 times 4 is 12x. Minus 3 times 1, which is 3. So numeric examples and algebraic examples. Now, either one, numeric or algebraic, you could do the way that I just did there by distributing. Or if you're familiar with the lattice method, we could do it by the box method. So the box method, I'm going to write what's in parentheses across the top. I put an X over one box and a 3 over the other because there was 2 spaces. We go write a number or variable there. Then on the side, I'm going to write 4. And then I can take x times 4, and that gives me 4x. And then 3 times 4, which gives me 12 plus 12. And that's my answer. 4x plus 12. So that's just a different method. You could do these either the same way that I did in the algebraic examples, or you could use the box method. So the second one, you notice is exactly the same. I put my 3 out there because there's only one of those. 2x squared plus 4x minus 1. And I can multiply 2x squared times 3, and that's 6x squared. 4x times 3 is plus 12x. And then 3 times negative 1 is negative 3. That's 6x squared plus 12x minus 3. What about a word problem? So the Hernandez family owns 2 cars. In 2009, they drove the first car 18,000 miles, and the second car 16,000 miles. If it costs 65 cents on average per mile to own and operate, find the total cost of operating both cars. So we know that we have 2 vehicles. One that went 18,000 miles and one that went 16,000 miles. And then they each cost 65 cents. That's 0.65. 0.65 cents per mile to operate. And this is an example where you would use the distributive property. So then we can distribute 0.65 to 18,000. And we get 11,700 plus. And we would distribute that 0.65. 0.65 times 1,600. And we get 10,040. And then we could add those to get our total for what it cost. 10,040 plus 11,700 gives us 22,100. So that's what it's going to cost for us to operate both vehicles. Now you have some YouTube problems. Go ahead and try it. Now let's look at combining like terms. It's on the back. When we're looking at combining like terms, we have to look at terms that have the same variable or variables and the same power. So they have to have the same exponent on that variable. So combining like terms, what's an example of that? Let's say if I have 2x squared y plus 3x squared y. Those are like terms because I have an x and a y in both of those terms. And the x is squared on both, and the y is to the first power on both. So I can combine these, and all I have to do when I'm combining these is add my coefficients. So this would be 5x squared y. Typically, when we write our answers, the last thing we check is we make sure that our variables are in alphabetical order. And then we order from least to greatest exponents. Now that's just something that you should be doing. We're not going to be very picky about it in the beginning because we know you're new to this, so combining like terms is really what we want to do. So let's take a look at some examples. To combine like terms, first use the commutative property to move like terms together and combine the coefficients. So we're going to do that. You may not need to do that later because you'll see them. But I see that I have 2a and negative 4a. So 2a minus 4a, I'm going to put them together, plus 3b. Now I have those two with like terms. I'm going to combine those. 2a minus 4a is negative 2a. plus 3b, because there's not another b, so it doesn't have a like term. Now I would check to make sure that my variables are in alpha order. They are a and b. And then I don't have to worry about anything else because I only have the one a, so I don't have to look at exponents. Looking at example 2, well, all of my n's are together except this n right there. He's a regular n, and the other two are n squared. So I'm just going to rewrite this. I'm going to put negative 3n squared minus 2n squared plus 3n plus 14n. I might have to change that around at the end, but for right now, that's what I'm going to do. So it has some like terms right here. Those are both n squareds. So negative 3 plus a negative 2 is a negative 5n squared plus 3n plus 14n. Now, technically, I should put this in alphabetical order. So, but it depends on which variable I would say. So let's say, and we'll actually get into this later. This would actually be fine. The answer, if we said to put it in alpha order of n's. But we'll put 14m first minus 5n squared plus 3n, only because I told you to put it in alpha order. Example 3, I can see right here that I have some like terms. I'm going to erase this previous problem because I went over my space there. So I have some like terms right here, 5x plus 4x, and when I combine those, that's 9x minus 6 plus 5x squared. So I want to put this in alphabetical order. So my x's need to go because negative 6 has no letter. And I have to put it in order of exponents. So my biggest exponent is 5x squared. And I have plus 9x minus 6. And that would be the correct order. And we'll get into that a little bit more later on, actually, in part 2 of the course. So let's look at an example of putting it all together. So what does that mean? That means we're going to distribute and combine like terms. So we have one example before you get to some you-dos. So in this example, we're distributing that negative 5. So negative 3a. A negative 5 times 2a is going to be a negative 10a. And then a negative 5 times 1 is a negative 5. And we have that minus 17 at the end. So we distribute everything in that parentheses, and then we just had a couple terms that weren't in the parentheses that are still part of the problem. So we have some like terms, this first two. We combine those, we get negative 13a. And then we have some like terms, the last two, negative 5 minus 17. So they're both negatives. Remember, when I have two numbers that are negative, I'm going to add them and just keep that sign. So it is minus 23.